I am Eric Hutchinson. I'm with the Division of Veterinary Resources. I am one of the organizers of this conference. So I get the lucky job of introducing the speakers this morning, a lot of the speakers this morning. But one of my favorite things about this meeting is the diverse experience and expertise that people bring to this effort. So in order not to fill all of your time with me babbling about the great qualifications of everybody that's here today, we do have in your packets a handout that lists the bios of all of our speakers. So I will try and keep them brief and with dazzling highlights. So first we have as our keynote speaker, Brenda Mcgowan. She has also been, luckily for all of us, a great help in organizing this conference. She's been our go-to person here at UC Davis and our point of contact in organizing this conference. Helped arrange the venues, helped arrange that awesome tour that a lot of you got to go on yesterday. So we're really thankful to her and also excited to hear her talk. She has 20 years, more than 20 years of primate behavior research experience. She's headed the UC Davis behavior program. She's a great researcher with lots of funding. So if you're looking for a job, I'm sure she's hiring at all times. She's going to talk to us today about her research on social networks. And obviously that's a pretty relevant topic for socialization of animals. And without further ado, Brenda.
Thank you, Eric, and thank you for inviting me here today to give you a talk on some of the work that we've been doing, looking at social network and social stability in large breeding groups of Rhesus macaques. And I want to go back to sort of historically very quickly just to say that when I was asked to join the behavior management program back in 2004 as a faculty of the School of Veterinary Medicine, I sat with the associate directors at that time, one of whom is in the audience here, John Capitani, and I said, "What do you want me to do?" And they said, well, a number of things, but one really serious problem that we've had over the years is these pesky little things called cage wars. And these cage wars are where animals in these large breeding groups completely collapse socially and have to be disbanded, basically removing more than 100 animals from the cage. So from that moment on, I began to really think about how to tackle this kind of problem. And since really very seriously since 2008, with funding from the National Institutes of Health, we've been able to really begin to understand cohesion and collapse in macaque societies. And we use this for both social management purposes, but also as a translational model for human social systems and their relationship to health. So I'll be talking today about a series of studies that my collaborators and I have been conducting since that time on network stability of Rhesus macaque social systems to improve animal health and well-being, and as I said, as a translational model for humans as well. So why are Rhesus macaques used as a biomedical model? Well, it turns out that Rhesus macaques are the most common biomedical non-human primate model that we have, and it's partly because they're not only genetically and physiologically very similar to us, but they're very hardy and adaptable and do very well in captive situations. And they're very much like us in that they're a weed species. You look in South and Southeast Asia, they have a really large distribution, and they're extremely well adapted to human contexts. In fact, so adaptable that Rhesus macaques are considered to be a nuisance in Asia and Southeast Asia. Great example of a Rhesus macaque stealing an ice cream cone, probably from a poor child. They're also very good at bartering for sunglasses as well. So they really are quite a nuisance in these contexts. And part of the reason why these guys are a nuisance probably has to do with their dominant style. Rhesus macaques live on a continuum of different kinds of dominant style, going from despotic to egalitarian kinds of communities. And Rhesus macaques are at the top of the despotic. So while we keep them in captivity, they're very adaptable, but they're also very despotic, which means that they have high degrees of aggression and lots of severity of aggression as well. So while keeping them in these breeding groups is great for a breeding colony doing biomedical research, they're very adaptable to these situations, and it promotes their species-typical behavior, and it promotes their individual health. We have some serious problems with trauma. Trauma needing veterinary attention, trauma leading to social relocations of these animals, and as I said earlier, social systems that fall apart and collapse, what we call social overthrows, or commonly known by our group as cage wars. So when we began to look at this problem, we started to look at this notion of what's going on in these kinds of social groups. And what we found, of course, is that there's variation in aggression within social groups, both in contact aggression and trauma. And this can relate a lot to the breeding season, a lot more trauma and aggression during the breeding season than outside of the breeding season. But what's more interesting is we also found variation across groups. So not all groups show the same amount of aggression, despite the fact that they have similar composition and density in these groups. So it's this variation that allowed us to begin to see how we might be able to pull apart some of the problems that we have with aggression in these groups and the social overthrows that occur on a periodic basis. So we needed a conceptual framework from which we could really begin to understand these processes. And we decided to look at a myriad of factors that really contribute to social stability and aggression patterns in Rhesus macaque groups. And this includes things like biobehavioral organization. For those of you who were on the tour yesterday, we talked about the BBA program, so we can try to use personality and temperament to understand in the groups how they contribute to these kinds of problems. We can also look at environmental or social stressors, such as kinship patterns. Density, of course, would be interesting. Composition of these groups, including things like sex ratio, which we'll talk a lot about today, and how that interacts with the social network structure, both at the individual level, roles of individuals in the networks, as well as at the group level, the network structure at the group level, and how that contributes to different kinds of health outcomes, including wounding and trauma. And I will be focusing today specifically on wounding and trauma, and not talk about some of the other health outcomes that we've been looking at as well as part of our translational work. Okay, so we have a conceptual framework now, right? We want to look at the myriad of factors that are contributing to social network structure, to individual roles in these networks, and how that affects wounding and trauma in these groups. But we can also take two different approaches, right? So we can either look at rates of behavior, rates of aggression. Remember, we saw variation in rates of aggression across these groups. Or we can take an internal look at the rates of these rates of aggression and look at the patterns in the relationships. So it's a little bit different than just looking at raw rates of aggression. It's about looking at patterns of relationships, and we need social network structure in order to do that. So let's do a little demonstration of social network structure. I'd like everybody who is coming from the primate center to raise their hand. Okay. Has anybody noticed that maybe they're kind of clustered in the middle there? And then I'm going to pick on one other group as well. How about the Ayakuk? Can I have the hands up from the Ayakuk? So what we're seeing here is that people are clustering themselves with respect to their relationships. And so it's these patterns in relationships that we really want to understand. It gives us more information about what's going on in these groups. So that the notion of this is not just clustering, but also this idea that there are direct and indirect relationships that are important. Does anybody in here know about the 6 degrees of Kevin Bacon? Would somebody please like to describe what that is? Loudly? Exactly. So the idea here is that you can reach Kevin Bacon through 6 degrees anywhere in the world. And it's actually true that there's been actually some work done using letters that show that you can reach anybody in the world in 6 degrees. It may even be shorter now because we have the internet. And I think it's actually a little bit shorter than as a result of some of our technological advances.
Just to give another example, if you see Ed Harris up there, well, his brother is Bob Harris, who's a lab animal veterinarian who just retired from Rutgers, so he's right snugged up against Kevin Bacon up there. Not a call.
Hey, now we only have 1 degree. Hey, all right, we're good. We're doing good. So this is what networks measure, okay? They measure both direct relationships as well as indirect relationships. And it's the concept that friends of friends actually matter, that these indirect paths actually matter. And so this is just a representation of that more formally, showing that we have the direct relationships, but it's also these indirect relationships that reveal hidden patterns in these relationships and how they can influence, in our particular context, aggression, trauma, and social group stability. Okay, so that's a nice little network. It's really easy to see those direct and indirect relationships. But what about if we pull up this terrace network? suddenly becomes a lot more difficult to quantify what's going on with respect to the direct and indirect relationships, right? So we need tools. We need a tool set for us to understand how these networks are structured. And what we've developed, along with our, there's standard network measures, but we've also developed some computational approaches, and I shouldn't say we, I should say Fuxing Hasai has developed computational approaches to look at these indirect and direct relationships in using data-driven, bottom-up approaches that have no underlying assumptions. And I will be using some of these today. I'm not going to go into detail about them, but I'll be using some of these today in order to show you what we have found with respect to these systems. Okay, so we're talking about our Rhesus macaques. How many of you were at the tour yesterday? Raise your hands. So all of you know that we got to see the large social groups. Lindsay did some positive reinforcement training and showed us some of talked a little bit about social structure in Rhesus macaques. And Rhesus macaque society, their origin is from South and Southeast Asia. Their social structure, they live in large multi-male, multi-female groups. The females are philopatric, that means that they stay within the social group, and the males leave, they disperse. The females inherit their rank from their mother, and we see a pretty strong dominance hierarchy in these animals, although they're not as linear as we once thought, based upon some of the work that we have done. The CNPRC groups mimic this kind of structure, except for one caveat to that, and that's traditionally natal males are not removed from the social groups, and this will become important in a little while. Okay, so our study groups are these 1/2 acre enclosures that some of you got to see yesterday. They range anywhere from 80 to about 200 animals, although we're decreasing the density actively. We've studied 16 groups so far in our population, and some of these groups are stable, and some of these groups actually had a social collapse, either while we observed them or after we observed them. So we were able to look at stability in these social groups. And we did this by looking at behaviors such as conflict, aggression, looking at what we call status signaling, which I'll describe more about later, and also affiliation. Okay, so we're going to take this conceptual framework of looking at the myriad of factors that actually influence social network structure and individual roles in the network, and look at how it affects wounding and trauma and social collapse. And basically what we found is 3 major pathways through which internal and external factors affect network structure and the social outcomes of wounding and social relocations. The first is matriline fragmentation, which I will not be talking about today. This is simply the idea that matrilines that have many cousins and not a lot of sisters are not as cohesive. Personality, which I will only touch on very briefly. And what I'm really going to focus on for this particular talk today is the role of males, the really, really important role of males in these social groups. Because the males are very, very important in maintaining social stability in these large social groups of Rhesus macaques. And we know this because we can first take a look at a very general parameter, sex ratio, and we can see that there's a negative relationship between the trauma per individual, so this is trauma over the total number of individuals, to standardize it, and we can see that when males are around, we have less trauma in these groups overall. But not all males are created equal. So the natal males in these captive groups can increase in rank if they are coming from high-ranking families. As we can see here, male rank on the y-axis and male's family rank on the x-axis. Males that are from high-ranking families are also high-ranking. And they gain that rank through untraditional methods. They're not doing it because they have power to become high-ranking. They're doing it through kin alliances with their sisters and mothers. Their mothers and sisters are supporting the males in increasing in rank by helping them in their alliances in interactions. So high-ranking males, natal males, who get support from their kin actually occupy really central positions, and that's what we're looking at here. You can see here the animals that are the natal males that get frequent kin support and are high-ranking are very central in their networks, meaning that they have a lot of connections, and they have a lot of connections to individuals who have a lot of connections, something we call Bondage Power. Again, friends of friends matter. And interestingly, they actually start more fights as they have increases in number of kin alliances per week, and they also have a higher frequency of intense aggression if they have more kin alliances per week. So these natal males, these high-ranking natal males, are problematic. Okay, so not all males are created equal. So then why do we have this relationship between sex ratio and trauma? What's going on here? If it's the natal males are problematic, then it's not all males that are helping with this particular type of problem. And to do that, we have to understand some concepts known as rank and social power. Okay? Now, to do this, we have to start talking about the direct and indirect relationships that I brought up before. Okay? So you can imagine that we can have a direct relationship between, you know, this individual here and this individual here, but we also have an indirect relationship between these two individuals, right? And we can have we can have pathways up to, you know, I think one of the highest orders for us go up to, or at least what we can measure is up to 7 orders. But we can have these indirect relationships where there's no direct relationship between two individuals, but there are these pathways that link them in terms of their dominance or aggression networks. So we're showing a 1-step pathway here in red, a 2-step pathway in blue, and a 3-step pathway in yellow. So you can also imagine, once you start looking at these indirect relationships, that there could be relationships that, through different pathways, either show consistency or do not show consistency. And this is represented here. So we can see in the graph on the right that if you go from F to G through H, J, and I, you have a consistent relationship from F to G, and you see that if you go from F to H to G, without going through that other pathway, it's showing consistency. So the black are showing consistent relationships. Whereas on the left graph, you can have these indirect pathways also showing inconsistent relationships, where you have a 2-step path between A and B, in which it goes in one direction, meaning that A is aggressing B, or you can have B going through a different pathway showing inconsistency with that path, meaning that going through that indirect path going from B to A. So this notion of these indirect pathways being important, but not just that they're important, but that the importance of the consistency of those kinds of relationships. And this becomes really important. So we can talk about dominant certainty, which is a little bit different from rank. So if we take all those indirect pathways and direct pathways, weighted by the direct pathways, of course, but there's not all individuals have a direct pathway, we can come up with what we call a dominance probability. So the example I'm showing here is 35502. Ashley, what's the name of that animal? Thank you. And 27993, there's a really strong relationship that 35502 is dominant to 27993, okay? And on the lower panel here, we can see that in the lower panel here, we have dominance probabilities that are very low, meaning that 38928 is very subordinate to 27993. Okay, so this is how we read these dominance probabilities. And we can get rank out of these probabilities by doing a bunch of shuffling using these really cool computational approaches, but we also can get something else, and that's called dominance certainty. Dominance certainty is the average across all of the individuals that you have a dominance probability with. And it tells you the degree to which you're certain about your relationship, okay? In this case, you're very certain about your relationship, but here you're also very certain about your relationship because you're really, really subordinate as opposed to really, really dominant. So if we want to get a dominant certainty, what we do is we minus the 1 from, we minus out from the lower part of this basic matrix, and we can get a dominant certainty that ranges between 0.5 and 1, and it tells us how certain those individuals are about their relationships, not just about their rank. And when we do that, we see a U-shaped function of rank against dominant certainty. So we have rank on the x-axis, we have dominant certainty on the y-axis, and you can see that individuals that are very high-ranking and individuals that are very low ranking have higher dominance certainty than individuals that are middle ranking. But we do see individuals that are high ranking that show low certainty, high ranking that show high certainty, low ranking that show high certainty, and low ranking that show low certainty. So we're decoupling rank from certainty. And this becomes important because if we look at dominant certainty and trauma, what we find is that the expected number of traumas per individual decreases with an increase in dominant certainty. So individuals who have high dominant certainty have lower trauma rates. Not surprising, right? And this is true of not just the rate of trauma, but also severity of trauma. So individuals with higher dominant certainty actually show less severe aggression as well. Okay, so now we have an idea of what dominant certainty is, we have an idea of what rank is. There's another notion that we need to understand, and that is social power. And social power is actually measured through a very different mechanism, okay, what are called silent bared teeth displays. Now, historically, traditionally, this behavior, this signaling system, has been thought to be a signal of fear. It's been called a fear grimace. But what we've discovered over the last several years is that silent bared teeth display is actually a multiple types of signals, and there's many different functions for silent bared teeth displays. And one of them, when produced in peaceful contexts where there is no aggression, but literally animals will walk up to another animal and give a silent bared teeth display, frequently looking at the animal very closely, as we see in this picture here by Lisa Parr from Emory University, is what we call peaceful SBTs. And it turns out that it's a formal signal of subordination that Jessica Flack and Franz Duval discovered, and we have and looked at in pigtail macaques, and we have been looking at in Rhesus macaques. And it essentially provides a consensus of subordination, a type of voting by group members that these animals are powerful. So we call this social power. Okay, so that's also a very important concept to take with us. Okay. So back to the idea of the roles of males and in these social groups. Well, it turns out that males play a really, really important role in intervening on the conflict of others in their social groups. And I mean others that do not provide any benefit to the male himself. So we see that males provide more policing behavior, what we call intervention or policing behavior, than females do. And we also find that unrelated males are more successful at these interventions, at policing third-party conflicts, than either related or unrelated females. And we think this is part and due that related males are really not policing their own alpha matriline, because they actually get a lot of support from their alpha matriline. And interestingly, if we look at social power from these status signals that I was just talking about earlier, we see that the predicted intervention success by males is higher as you have higher social power, and particularly in males. And everybody's going to love this. So the other thing that we find is that if you take a look at social power against intervention success, and you now plot some of the biobehavioral stuff that we do with these animals, in males and not females, tolerant individuals are better at intervening on third-party conflicts than either bold or unpredictable. And yes, I am going to refrain on making any comment about our current presidential campaign. I don't know if I wanted that recorded, though. Okay. So it's really, social power is really important. These SBT signaling systems are really, really important. It's so important that we've deemed them what we call a keystone network. It turns out that these SBT networks are extremely directed and transitive, meaning that they have no cyclic pathways. There is no inconsistency in these networks. You do see an inconsistency in the aggression networks, but you do not ever see any inconsistencies in these SBT networks. It also turns out that the multi-level structure, these indirect pathways that I've been describing to you, is also extremely important to stability in these groups. And it's associated, as we've seen, with conflict policing behavior. So here are some examples of some really strong, stable SBT networks, keystone networks, in our stable social groups. You can see that it's multi-level. There are a number of indirect pathways. There are also direct pathways. A lot of cohesion, a lot of connections between individuals. And this is what we're looking for when we're looking for stable social groups. In fact, if I briefly show you what happened in one of our social groups back in 2009, we showed multi-level structure when it was stable, and then we continued to collect data, and after we finished collecting data, this group fell apart. We had a social collapse. So we see a complete breakdown of this SBT network prior to social collapse in these groups. Okay. Another example, I'll be coming back to these to discuss a little bit more about how we can look at these kinds of stable and unstable systems. But again, multi-level structure, lots of connections, completely falls apart, but right before a social collapse. And I just want to point out, I have here this paper, Fuching et al., 2014, one of our papers in the International Journal of Forecasting. We actually used this model as a way to talk about how we might be able to use these kinds of methods to predict financial collapse in human social systems. So monkeys are good for a lot of things. Okay. So again, back to this idea of direct and indirect pathways. Very important that we have these indirect pathways, not just the direct pathways. And it turns out that if you have lots of SBT pathways, these indirect pathways, that you also have a lot of certainty and dominance. So what we're seeing here in green is a lot less variation in the dominance certainty for individuals that have multiple paths in their SBT network. Meaning basically that if you have more SBT pathways, you tend to have greater certainty. Okay? And this is important because the more signaling pathways you have in these networks, direct and indirect, we find we have greater conflict policing in these groups. So individuals that are doing the conflict policing have a higher number of these power pathways. Okay. So I hope at this point we know how important the SBTs are toward conflict policing, which can lead to stability in social groups and reduce trauma. So the question we have is, do these high-ranking NATO males destabilize these power pathways and the structure of these SBT networks? So recently, in the last few years, we've been doing some experimental work, doing what we call natal male knockouts, kind of like a gene knockout, but instead you take out a social entity in the group. So what we were doing is we were removing these natal males, not necessarily specific individuals, as opposed to the role that they were playing. So we removed high-ranking natal males because of the role we think that they were playing in these groups. And we basically did 6 weeks of baseline, 6 weeks of post-intensive, and 8 weeks of follow-up at a less intensive schedule. And that's to test the idea that whether or not high-ranking males actually destabilize these groups. And the answer to that question is it depends on the type of natal male, the type of high-ranking natal male. In some groups, what we found is that when we removed the natal male from the group, we did not see an increase in the complexity of the structure of these SBT networks. And what's interesting is it's in the case of where the natal male, the natal male is beginning to have his own SBT network. He's stealing SBT pathways from the alpha male, is where we actually see an improvement in the complexity of the SBT network. Whereas natal males that are not causing problems, they're within the SBT network of the alpha male, does not improve the complexity and structure of these SBT networks. So it actually matters who you are. It's not just all high-ranking males are nasty. And we can look at this a little bit differently in that we can take a look at these indirect pathways and the ratio of these indirect pathways with respect to two-step paths, three-step paths, and four-step paths to see if there's an improvement in that structure, right? So if you have a greater ratio of two-step paths to one-step paths or three-step paths to two-step paths, it means you have more complexity and more indirect structure in that network. And we can do that, as I just said, by looking at the ratio of those things. And when we do look at the ratio of these indirect pathways, what we find is that in the natal males that are not problematic, we do not see a change, an increase in the ratio of these paths. But we do in the ones that where the natal males are problematic. And this one just represents here sort of an ambivalent one, where we see some improvement, but not all improvement. And we can then begin to look at the change in the ratio, whether it's increasing or decreasing. We can begin to look at natal male attributes and behavior that might contribute to the trends that we're seeing here. So we looked at a number of different kinds of males' behavior, but I'm going to focus mostly on group fights, percent group fights, natal male supporting kin, and the dominance probability with the alpha male. So remember, the dominance probability is whether you're dominant to an individual or not. If it's higher, then the alpha male is more dominant to the natal male, and if it's less than it, the natal male is more dominant to the alpha male, sort of. Yeah. Okay. So let's take a look at that. So if we look at the change of the ratio of 1 to 2 step and look at the percent of group fights that are started by the natal male, what we find is that when natal males were not problematic, the complexity did not improve, and we see, so the number of group fights actually is associated with natal males being problematic and complexity actually improving. In green, complexity not improving in red, and the equivocal one in yellow. Okay, so if natal males are starting more fights, then removing them is a good thing. Same with agonistic support given to kin by natal male. So if the support is given to kin by the natal male, then we see that it improves if we remove the animals from the group. Okay, the green means that it's improved. And then finally, a dominance probability between natal male and alpha male. We find that if the dominance probability is if the natal male is close to the dominance probability of the alpha male, removing them is a good thing. So it shows the opposite relationship as the others. Okay. If the alpha male is really dominant, quite dominant to the natal male, then removing them doesn't change anything. Okay, so we're getting a sense of how these individual males, natal males and alpha males, are interacting with each other. So I now want to turn to looking at social power and group stability. So we've been looking sort of at the individual level, what's going on. So let's turn to looking at group stability and social power. And here we're going back to this notion of SBT networks and stable and unstable structure. Just to give you an example of sort of how we look at these things, we had several groups that actually we watched for a year, and then they would socially collapse at the end of that time. And there were other groups in which we would be watching the animals, and they'd socially collapse while we were actually watching them. So we really have an interesting set of groups that we can look at with respect to this. So what we tried to do in terms of looking at SBT networks and structures, we also wanted to look at how two different networks would actually correspond to each other. So not just that we have an SBT network that we're worried about, but what happens to the SBT network in relationship to the aggression network. And this is a tool that we use called joint network modeling, which basically allows us to look at the number of dyads that actually show these different kinds of patterns. So here I'm showing bidirectional aggression with bidirectional status. Doesn't happen all that often, and these we count basically the number of dyads that fit this pattern. Another example of this would be to remove the bidirectional status and just look at bidirectional aggression. And here's an example of that where we have two bidirectional aggression but no status signaling. Okay, so we can count the number of dyads for each of these different things. And we can get a graph or basically a table that tells us the total number of observed dyads under these different contexts, noting that most of them had zeros, no interaction at all, okay? And we can then do an expected dyad, the expected number of dyads. We expect to show this just by chance, okay? And this is this notion of independence. And we can actually add these up using a chi-squared technique that allows us then to look at what happens when we start making other kinds of assumptions. So we start with a null model, which is the chi-square value that you get from just looking at the observed minus the expected, or basically the absolute value of that. And then we can start to add what we call constraint functions, where we can actually say, well, 2A regression is really rare. and we can see how it changes the chi-square value. If it's important, it will decrease the chi-square value, okay? We can then ask, what maybe a second function? Two-way status signaling is rare. If that's important, it will also decrease this chi-square. So both two-way aggression and two-way status, they do decrease the chi-square function a bit. But the third function, aggression and status, are in opposite directions. That means that I give a status signal to an animal that's very dominant to me, shows a huge effect on the chi-square value. So it's extremely important to group stability, okay, that you see aggression and status in the opposite direction. So what happens if we take a look at stable and unstable groups? Let's first start just with stable group. Don't worry so much about the absolute value of these things. It's the pattern that's occurring that we're interested in. And in the stable groups, we see the same pattern over and over and over again over many different periods. These are all just different periods of data collection that you're seeing. And it shows the same pattern. There's, two-way aggression is, contributing a little bit, two-way status signaling a tiny bit, but the really big the really big result is that there is opposite direction of aggression and status signaling. When we look at the unstable groups, what happens is that begins to completely fall apart. We see that actually two-way aggression actually increases here. It becomes more important, and we start to see the sort of the disintegration of the importance of the opposite aggression and status signaling. And it's much more, actually, it's much more illustrative here, where you can really see that starting to fall apart. It no longer has this huge drop. In some cases, you see it happen immediately, and then in this third case that we're looking at here, we just saw a gradual disintegration of this joint modeling of aggression and status signaling. So in summary, peaceful SBTs represent a keystone network that leads to dominance certainty and provides opportunity for conflict intervention that leads to social group stability. These peaceful SBTs are mostly given to high-ranking males, although I'll note that we do have another kind of SBT that is given during the breeding season, and that's by males to females. So it switches around a little bit when there's stakes that there's stakes for mating opportunities. But we think it's a completely different kind of signal. In fact, males almost never give females peaceful SBTs. It's almost always females giving high-ranking males or other males giving high-ranking males SBTs. High-ranking males, we've shown, can disrupt these peaceful SBT networks. They steal SBTs from high-ranking unrelated males. And these disrupted networks can lead to the disintegration of peaceful SBT networks and the decoupling of aggression and status networks that is predictive of social collapse. So we can use this to predict social collapse and prevent trauma associated with these events. So I hope I've shown how important the role of males are in these groups, and particularly the high-ranking unrelated males. In fact, we think they're so important that we'll be starting a new R24 come this summer, where we will be trying to introduce males into social groups. Yes, I know, Ashley, I know. I know you're worried, but it's really quite important. So we want to learn how we can get good, tolerant, high-ranking, unrelated males into these groups. And as I've said, we've done some other network stuff that I'm not presenting today, showing other kinds of pathways that contribute to this kind of stability. I also hope I've shown the importance of looking at the myriad of factors that interact with these social networks and individual roles in these networks to produce these kinds of health outcomes: trauma, wounding, social relocations, as well as actually a number of other kinds of health outcomes that we are currently looking at. And I finally like to say that the system science network approach, instead of just pure basic rates of behaviors, really has given us greater insight into the processes leading to these higher rates of trauma and social group instability. And because it's the beginning of the social housing conference, social housing, of course, is critical for better welfare and research outcomes. But as I'm showing this morning, I think we'll see throughout the venue here, it can be quite challenging and complex. And with that, I'd just like to acknowledge all of my collaborators, the observation team that does amazing work out there, and of course the